Lesson 7.4, trigonometric ratios. A trigonometric ratio is a ratio of the lengths of two sides of a right triangle. All right, the three basic trigonometric ratios are sine, cosine, and tangent, which are abbreviated as sin or sine, cos, and tan. Below we have a chart that summarizes everything having to do with these trig ratios. So the first thing you must understand, and it's the most important thing you must understand, is the naming of the sides when you're working with trig functions. So we're going to be focusing on an angle. In this particular case, we're focusing on angle A. Okay. Now, across from angle A is what's known as the opposite side. The side across from the right angle is always known as the hypotenuse. And the other side left over, the side touching the angle, is your adjacent side. Now, the naming of the sides never overlaps. There's always one specific opposite side, one specific adjacent side, and one specific hypotenuse. They never overlap, okay? So when we're working with sine, it's always sine of some angle. In this case, it's A. So the ratio for sine is opposite over hypotenuse. So I have opposite, which is A, over the hypotenuse, which is C. Okay. For cosine, the ratio for cosine is adjacent over hypotenuse. So adjacent over hypotenuse. And for tangent, it's opposite over adjacent. Opposite over adjacent. Now you may be saying to yourself, how am I going to remember this? Well, here's a very helpful acronym to help you remember the ratios. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So all you have to remember is so, ka, toa, and you'll know what your ratio is for the trig ratio that you're working with. All right. The big question I'm always asked is, what is the purpose of trig ratios? All right, here's a little explanation below. All right, trig ratios are only applied to the acute angles of a right triangle. So I've seen students do this, where they apply a trig function to the right angle, and they're getting the wrong answer. Things are weird, something is going wrong on their calculator, they don't know why. All right? You don't apply trig functions to the right angle. You apply it only to the acute angles of the right triangle, okay? And what it helps you do is it helps you solve for the other two side lengths of the right triangle when you only know one of them. Okay? So for example 1, let's build up our knowledge here before we begin to see how trig functions are really applied. Label the sides that in relation to angle A are opposite, adjacent, and hypotenuse. All right, so think about it for a moment. Which side is opposite to angle A? That would be this one. This is your opposite. That's your O. Which side is adjacent? This is your adjacent side. And which side is your hypotenuse? This is your hypotenuse. Okay. For part B, label the sides that in relation to angle B are opposite, adjacent, and hypotenuse. Okay, be very careful here. Which angle are we talking about? B. So what's opposite to B? That would be this one right here. What's adjacent to B? That would be this one here. And what is the hypotenuse? Right there. Okay. For example 2, find the sine, cosine, and tangent of angle A and angle B. All right. So here I have sine of A, cosine of A, and tangent of A. Okay. Relative to A, this is your opposite, this is my adjacent, this is my hypotenuse. So sine is opposite over hypotenuse. 5. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Alrighty? Now we're going to apply the trig functions to angle B. Sine of B, cosine of B, and tangent of B. Okay? So sine of B, working with B now. Alright? So the hypotenuse stays the same, but now the 4 becomes your opposite and the 3 becomes your adjacent. Alright, see how you really have to know what you're doing here when it comes to labeling? So you have opposite, which is 4, the hypotenuse, which is 5. Alright, for cosine, adjacent is 3, hypotenuse is 5, tangent is B, so I have opposite, which is 4, and adjacent, which is 3. Okay? If you understand all this, then you're going to have not much difficulty doing the real problems. Example 3, find the value of each variable. Okay, here we go. I have this angle to work with. I'm trying to figure out the side opposite to it, and I have the hypotenuse. So now you have to ask yourself, which trig function involves opposite and hypotenuse? That's going to be sine. So it's sine of the angle that you're working with, which is 37 degrees, and that's equal to opposite, which is x, over the hypotenuse, which is 6. Okay? So that's your setup. That's the most important piece. If you know how to set it up correctly, then you're on your way. Now, how do I get x by itself? I multiply by 6 on both sides. All right, first mistake that students make is they multiply these two numbers. Okay, do not do that. Okay? This itself represents one number. Don't mess with it. Okay? So now you're going to punch this in on your calculator, 6 times sine 37. Okay, and what do we get for x? X is equal to? Okay, we get 3.61089 and so on. Okay, I want you to round your answers to the nearest hundredth. All right, so this is 1,000th place, and it's less than 5, so this stays 1. All right, so x is equal to 3.61. All right, that's all there is to it. When you're using a TI calculator, be careful. Make sure your calculator is in degree mode, because if you're using a calculator that a calculus student used or a pre-calculus student used, their calculator might be in radian mode, and it's going to throw off your answers. So make sure your calculator is in degree mode. All right, now for part B, what do we have here? I'm working with this angle. I'm trying to figure out the adjacent side, and I have the hypotenuse to work with. So which trig function would you apply? You would apply cosine. Cosine of 22 degrees is equal to x over 8. All right, how do you get x by itself? Multiply by 8 on both sides, cancels out, and you get x is equal to 8 cosine 22, 7.41747, and so on. Once again, round to the nearest hundredth. All right, the 1,000th place is greater than 5 or greater, so this becomes a 2. So I have x is equal to 7.42. For part C, all right, I have the 62-degree angle here. I have the opposite side that I'm trying to find, and they give me the adjacent. All right, so I'm going to be using the tangent function. So I have tangent, 62 degrees, and that's equal to x over 15. All right, to get x by itself, multiply by 15 on both sides. All right, plug this into your calculator, and we get x is equal to 28.21. Okay, I'm rounding it off here. All right, let's do a couple more examples. All right, so notice that x was always in the numerator position every time we set up the ratios. we're going to have a different scenario in these examples. So here I have the opposite side, and I need to find the hypotenuse. So I have sine of 37 degrees is equal to 6 over x. All right, how do you get x by itself? Well, first thing you have to do is multiply by x on both sides. That cancels out. You get x sine of 37 degrees equals 6. All right, just take it step by step. Now I divide by 37 degrees. Okay, so x is equal to, I take 6 and I divide it by sine of 37. And that gives me 9.97. Done. All right, let's do another example. Now I have adjacent and I have hypotenuse. So I have cosine of 22 degrees is equal to adjacent, which is 8, over the hypotenuse, which is x. All right, multiply by x on both sides. X cosine of 22 degrees is equal to 8. Divide by cosine of 22 degrees. And x is equal to 8.63. I'm going to be rounding up in this case. Let's do one more example. I have adjacent and opposite. So I have tangent of 62 degrees is equal to opposite, which is 15, over adjacent, which is x. So I multiply by x on both sides. I get x tangent of 62 degrees equals 15. Divide by tangent of 62 degrees. All right, and x is equal to 15 divided by tangent of 62 degrees. Done. 7.98. Alrighty. You may have noticed that if the variable's on the bottom, then you could just switch these two parts, okay, to isolate the variable. But I just want to make sure you know how to do the proper mathematics. All right, let's do a couple more examples. All right, approximately how many feet tall is the streetlight? I'm trying to figure out the opposite side of this triangle. They give me the adjacent. Here I have a 40-degree angle to work with. So which trig function will we apply? We will apply tangent. Tangent of 40 degrees is equal to h over 20. All right, so I'm going to multiply by 20 on both sides. Cancels out. So I have 20 tangent of 40 degrees. All right, notice that they give you an approximation up here. So if you didn't have a calculator, this is the reason why they give you this little chart here, so you know which decimal to include for tangent of 40. So I'm going to use what they give me, 20 times 0.84. And then you could work that out by hand. Okay, so what do you get? 16.8. In this case, feet. There's your height. Done. All right, for part B, in the figure below, sine of A is equal to 0.7. What is the length of AC? All right, AC is the hypotenuse of the triangle. They give me this piece of information here. This is key. I'm working with angle A. All right, this is the side opposite of angle A, and I'm looking for the hypotenuse. So I'm going to be using sine. Sine of A is equal to 21 over the hypotenuse, which is AC. Okay, now what do you do here? Well, I don't know what the angle measurement is, but they gave me this information here, so just substitute it in. So I have 0.7 is equal to 21 over AC. Okay, multiply by AC on both sides. Cancels out. I get AC times 0.7 is equal to 21. Then I divide by 0.7. And AC is equal to 30. All right. Two more examples. Right triangle ABC is pictured below. Which equation gives the correct value for BC? Okay, here they have sine of 32. Sine is opposite. All right. If I'm working with 32 here, this is opposite, adjacent, hypotenuse. All right. So I have BC is opposite. That's true. And then the hypotenuse should be 10.6. That's not happening. Cosine of 32 is adjacent. Adjacent is not BC. So that's not happening. Then it says, wait, look at this. It says tangent of 58. Where did the 58 come from? Well, that's the other acute angle here. So just subtract 90 and 32 from 180, and you get 58. So now I'm working with angle B. So now this is opposite, this is adjacent, and this is hypotenuse. So tangent is opposite over adjacent. Opposite, that's 8.2. Adjacent is BC. That's my answer. And then we'll just go to D just to show that that's an incorrect answer. Sine of 58, sine is opposite. It should be 8.2. It's not, so that doesn't work either. Okay? For part D, in the figure below, if sine of x is equal to 5 over 13, what are cosine of x and tangent of x? Okay, so sine of x, we don't know what this angle measure is here, but we have sine, which is opposite over hypotenuse, so this is going to be 5, and this is going to be 13. Okay, how do you figure out the adjacent side? Well, you could use the Pythagorean theorem, or if you look at your bag of tools, you have the Pythagorean triples to work with. So you have 5, 12, and 13. All right, so that makes doing this problem a bit faster if you could draw on that knowledge. Now we have cosine of x is equal to adjacent, which is 12, over the hypotenuse, which is 13. And tangent of x, which is opposite over adjacent, which is 12. All right, and now we're done. So there you have it. There's trig ratios. It's a very powerful concept. And when you get to pre-calculus, you begin to see how trig functions are applied to waves, sound waves, all different types of waves. And that's when it becomes really, really interesting. All right. If you have any questions, please make sure to ask. Begin the assignment now.